Thank you so much for having me. And just before I start my presentation, I remembered this morning the several informatic conferences I had attended when I was much younger during my PhD. So I have very warm feelings now that I am given the opportunity to return. Especially in this session about semantics, which is the area I've trained in as a researcher. So in this short talk today, I'm going to tell you a little bit about some of the studies we've been doing in my team, where we're exploring knowledge graphs and knowledge bases as socio-technical constructs, which are created by following specific knowledge engineering processes and supported by technical capabilities. But ultimately, in my work, I am trying to study this link between the makeup of a community or the social fabric of a knowledge graph as a function of the context in which it is created, and their technical qualities and abilities to be used automatically by machines. This is by no means a new idea. There are several reference studies, including in the semantic web community. The one that I've cited here is from 2005, Ontologies Are Us. So this was one of the first and most referred to paper that has looked at how an ontology or a knowledge base changes in terms of classes it has, in terms of the shape of the taxonomy, the number of instances and how they're classified based on the social context it emerges. So in my research, I take this sort of idea and theme a bit further by applying specific theories from online communities, sociology, and related areas to environments where a group of people supported by AI, by bots, come together to create these critical AI resources that are knowledge graphs today. So in the talk, I'm going to specifically go into two studies where we've looked at editors and editing behavior and their impact on the quality of knowledge graphs. And this is important because knowledge graphs like DBpedia, Yago, the Google Knowledge Graph, Wikidata, they are used extensively in a range of AI applications, for instance, in intelligent assistants and chatbots, but also for search and many other applications. So the quality of the information that is included in these knowledge graphs has a huge impact on the quality of the services that use the knowledge graphs down the line. This is part of a longer talk where there is a second part where we're actually showing that the same sort of socially inspired methods not only provide signals into the technical qualities of the knowledge graphs, but can also help repair specific quality issues. So the studies in this talk are all about Wikidata, which some of you might know as a project of the Wikimedia Foundation that creates the structured backbone of many Wikipedia projects. As of today, it has around 23,000 active users and no less than 89 million items, so nodes in that graph, with no explicit ontology. So that means that the graph is created organically, and some nodes in that graph can be considered as classes depending on our definition of what a class is, but there isn't that structured knowledge engineering understanding where a class or class taxonomy is created, then the graph is populated, which leads to changes in the taxonomy and so on and so forth. The background for the two studies I'm going to present comes, as I said earlier, from existing empirical studies and the theories from social sciences and online communities, where one has established in various contexts that group composition can have multiple effects on the work that the group produces, that the length of a tenure and the diversity of interest could increase the quality of the outcome as well as group productivity, and that organically, when editors have the freedom to work on whatever they are interested in, they will focus on different types of activities and build different types of skills and social structures. So starting from these insights, we wanted to see to which extent they apply to the Wikidata community as well. So the first study specifically looks at how some of these aspects impact on item quality, and to do that we have looked at a data set where we have the entire history of all edits done by all people and bots on the Wikidata items, and in particular we look at 5,000 of these items whose quality has been manually assessed. So the community in Wikidata has established these 5 levels, quality certificates, quality labels, and we have already a corpus of 5,000 items for which we have an understanding of what their quality is. And we compare this against the edit history, in particular those attributes in this data set that gives us insight into the community makeup. Community in this case is defined at an item level as the set of editors that have contributed in whatever form to creating or changing that item. And for group diversity, we look at features from existing literature mapped to Wikidata, as you will see in a short while. So the hypotheses are really, we wanted to look at the relationship between different types of edits, automatic edits done by bots, which are scripts that the community creates to carry out certain types of activities. We wanted to look at the effect that bot human interactions have on item quality, anonymous edits, as well as the diversity of tenures, so communities that mix newcomers with more experienced editors versus interest diversity as well, whereas interest is defined in terms of the classes, the topics, main themes of the items that someone has edited. So we've done an ordinal regression analysis where we've trained 4 different models with increasing levels of complexity, and for all models we've basically looked at the relationship between the independent variables listed here, which are direct mapping from the hypothesis, and the dependent variable, which are these 5,000 Wikidata items, each with a label from A to E. And we've controlled for group size, so the number of editors that have contributed to an item, and how old an item has been, so when it was created. In a nutshell, all hypotheses were indeed supported. So we can see that in Wikidata, just like in other online communities and scenarios as well, we have the same sort of group effects, social effects that other studies and theories have foreseen. What does it mean in terms of Wikidata and how it is managed as a community? Well, more editors for an item doesn't always mean higher quality. So especially for anonymous edits, they do take, at least according to these 5,000 items that we have analyzed, they do have a negative impact on the item quality. So one direct implication would be to try to find ways in the Wikidata platform to encourage registrations, to create incentives for people to register. The other thing that we have seen in the analysis is that automation is important. So items where some sort of automatic processing has been applied to edit some parts of the item have led to better quality, which is which is good to know and reassuring, because that's the only reason why you would want to have automation. But in the same time, when you have a combination of human, so manual edits, and automatic edits, they lead to even better quality. So the question there would be, on the one hand, how to identify systematically areas for bot editing, and perhaps also to look a bit deeper into the quality of these human bot interactions and how these could be improved, because they seem to have to be really important for the quality of the outcomes. Registered editors have a positive impact as well. So you really need to think about how those workflows look like, and how you would encourage registration further down the line. And finally, just like in many areas before, diversity really matters. So items that have been edited by people with different tenure lengths in Wikidata are better. This could be because newcomers tend to focus on other types of tasks and contribute in their own way to improve the quality of the items. But it also points to a need to perhaps on the platform provide capabilities for item recommendation that are based on tenure and interests as well, because the study shows that overall it does impact the quality of the items positively. So now we're going to move to the quality of the underlying ontology. So this is the second study we've done a year or so ago, where we've looked now at the entire knowledge base. So we looked at the ontology specifically, and you may remember at the beginning of the talk I said that this ontology is created organically. And we do a similar type of study. So we look at the edit context, at the social context in which this artifact, the ontology, was created, and try to infer links between the makeup, the social makeup, and certain ontology quality features. The ontology itself, we define it as the graph of all, the sum of all items that are linked by two types of properties in the knowledge graph. One is instance of, one is subclass of. And then we calculate how specific quality metrics from the literature, more about this in a sec, have evolved in time, and how the editing activity of the ontology editors has evolved in time as well, and the effects it has had. So we looked at 55 months of editing behavior. We've carried out a literature survey to define what quality is. We've clustered editing activities to identify typical roles, organically created roles, and then we've run a multiple regression analysis to link specific roles to ontology features. So for the metrics, really quickly, these are based on a lit review of various ontology evaluation frameworks, and we've identified these various indicators which apply and can be measured on Wikidata. The measurements basically confirm that, well, it is a huge ontology, but it has also quite important quality issues. In particular, it is of uneven quality. So some of the things that we've noticed in the analysis is that the number of classes seem to increase at the same rate as the number of items or instances, which is a bit problematic if you consider classical ontology engineering. Similarly, an argument like AP, which is the average number of instances, decreases over time. So you see lots of classes created without instances or subclasses or both, which in ontology evaluation, again, is flagged as a potential issue. If we look at roles, which we have established by applying a k-means algorithm using features from the literature, which are listed here, we identified at least two types: a so-called leader role, which is around 1% of the editors in the corpus that have a higher number of contributions to the ontology, are more engaged with the community, versus a second cluster of so-called contributors that have lower number of contributions to the ontology itself, and edit also in a different way. Now, people who joined Wikidata earlier tend to be more in that leader role, to be more active, are more likely to become leaders, but their levels of activities decrease over time, which is an interesting result that we would need to look into to try to understand whether it's a motivational issue or whether they go on and do other tasks. So now to make the link between roles and quality, we basically wanted to see what the effects are when leaders, when more experienced, more seasoned contributors interact with the system. And we found out basically that for H1, which was the hypothesis linking leaders to number of classes, number of root classes, number of leaf classes, the hypothesis is not supported. So this basically confirms the fact that because of the organic nature the ontology is created, that increase in the number of classes and taxonomical properties can also be due to less experienced editors just using properties in an unintended way. Whereas we could find some support for the second hypothesis that basically says that it's mostly the experienced editors that evolve the taxonomy. I will conclude now. So creating ontologies is still a hugely challenging task. So at the beginning of the study, we have actually tried to apply some previous frameworks for measuring or evaluating ontologies, but the size of this one, which I think it was millions of classes or so, made those methods totally unfeasible. So this is why we went ahead and did these sort of analysis. There is more to be done in terms of how to support newcomers in doing ontology engineering, so at the level of defining classes, properties, and so on and so forth. We also don't know exactly why leaders, so seasoned editors, decrease in their level of activity in time. And this is some of the stuff that I would want to leave you with to conclude, which are the things that I would like to work on. So some follow-up questions around how bots contribute to this activity, and perhaps compare the bots that are currently responsible or co-responsible for creating some of the ontology with what we know from ontology learning or automatic knowledge-based construction. Also, to run a similar study perhaps on checks schemas. So checks is this formalism that allows one to define these small schema snippets, which are used now in Wikidata as well. And further down the line, if anyone is interested in a collaboration or a PhD, what is the role of social interactions for ontology engineering? So this is a very rich environment that includes discussions, arguments, and so on and so forth, which have always been quite key questions in ontology engineering. The role of conflicts and conflict resolution, especially in such an open environment where, at least in the first years, everyone was allowed to edit the ontology at whatever level, and then other diversity aspects beyond the tenure of the editors and their interests. And these are some of the publications. Highlighted are the ones where we describe the two studies if you're more interested in the methods. So if you have any questions, I'd be happy to take them on now.